pass by reference versus pass by value. Same exact idea. It basically gets at something we talked about that we saw a little bit of on Tuesday, which is this idea of essentially, why is it that when we compare objects using the triple equal signs, it doesn't really work, or at least it doesn't give us what we think it does. And then we'll talk a little bit about copying values back and forth of all data types, not just the complex ones. So we'll start with a quick review on primitive versus complex data types. We'll talk a little bit more in depth about variable assignment and how those values are actually used in functions, and then we'll end with talking about the equality operators and how that plays into it, and also why dot slice is actually a very powerful tool beyond just allowing us to segment part of an array. Okay, so those six are the primitive data types in JavaScript: strings, number, booleans, undefined nulls, and symbols. For our purposes, undefined nulls and symbols we won't talk about too much other than just say that they exist. We'll be primarily focused on strings, numbers, and booleans. On the complex side, we have objects, which includes arrays as well. So arrays and objects are both considered complex data types in JavaScript, as well as functions. So why is it? Oh, sorry, I wasn't in presentation mode. So what makes complex and primitives so different? Well, strings are what we call primitive values, and so fundamentally, what that just means is that primitive values cannot be changed. And so here on line two, if I create a variable and I call it British city, and I assign the value of York, and then beneath it, on line three, I say let this variable called American city equal to the value of British city, then it stands to logic that after line 3 runs, both American city and British city will both equal York. Now, if I then edit American city and set it equal to new plus the pre-existing value of American city, which is York, I get back New York. And so I know that American city is now equal to New York. The question is, what is British city equal to? And if I console log out both of these values, these are really hard to say actually. When I console log out both of these values, I see that British city stayed York, whereas American city was replaced with New York. And so this is kind of one of the key differences between primitive, or one of the key behavior traits that we see among primitive data types is you cannot change a primitive data type. You can only reassign it. On line 2, we assigned the variable British city with the string York. On line 3, we assign the primitive value, or we assign the variable American city with the primitive value of York as well. On line 5, even though we're changing American city, notice how we're not just editing it, we're actually replacing the previous value of American city with a brand new value. Notice that assignment operator there on line 5. We're not replacing the variable British city at any point, and that's why when we print it out, British city was never changed after we initially gave it the value York. American city was, and it's now equal to New York. If we look at the same behavior with arrays, which are complex data types, we'll see something different. Here on line 2, we have our British city variable, which is equal to the array York. On line 3, we set it equal to British city. And on line 5, what I'm going to do is I'm going to add another element called new, the string new, into the beginning of the American city array. So after line 3, both British city and American city are equal to an array with a string of York. However, when I edit American city by adding another element to the beginning of it, as you can imagine, American city becomes an array with two elements, new and York, but so does British city. And so this behavior, this inconsistency is kind of at the heart of what we're going to be talking about today, and why this is so valuable. Okay, when we assign a value to when we assign a primitive value to a variable, what the variable is actually doing is that it's actually creating and storing a copy of that variable. And so here on line 4 here, I create a variable called first and I give it the value of 20. And so in the computer's memory, if we'll call it that, it will create a variable called first and it will give it the value of 20. On line 5, we then replace that value with now 30. And so the variable first is now storing the value of 30. On line 7, if I create another variable and I set it equal to 30, well, even though both first and second are now equal to 30, the copy of 30 that belongs to the first variable is different than the copy of 30 that belongs to the second variable. And that's why if I change the second variable, it has no impact on the first variable. I think most people can intuitively get this, right? The analogy that I usually give is if I buy a car and my friend buys the same exact car, well, we're not sharing the same car. We just happen to have two different versions of the same car, right? So here, same idea. After line 7 runs, both first and second have the value of 30, but those values are not the same. They're not overlapping, right? They're distinct copies of the same value. And so changing one has no impact on the other. Ta-da. Now, what if we do something different? What if here we say let first equals 20, so we still create our variable called first, and we give the value 20. And then afterwards, we said let's create a variable called second, and set it equal to the value of first. At this point, what the computer is going to do is it's going to take a look at the variable first and say, what kind of value are you? Are you a complex value or a primitive value? And first we'll say, I'm number 20, so I'm a primitive value. And because it's a primitive value, what JavaScript's going to do is JavaScript's going to make a copy of the value of first. So in this case, it's going to make a copy of 20, and it's going to store that inside the second variable. And so if you look on the bottom right-hand corner of our screen here, right, same exact behavior as before. We have two variables, first and second. They're both equal to 20, but they're both storing their own distinct copies of 20. And so whatever we do to one version has no impact on the other version, right? This is what we mean when we say pass by value. Is that when I assign one variable to another, I'm actually assigning a copy of the value. Okay, so this is how it works for primitives, and this applies to numbers, strings, and booleans. Now, if we move on to complex values, it's a little bit different. When we assign a complex value to a variable, we're actually not storing a copy of that value. We actually are storing that version of that value. So, generally speaking, when we store something in a computer, it has an address in the computer's memory. We call that the reference, and the reference tells you where the value is, right? And so here on line 7, when I create the variable called first, and I set it equal to the array 10, 20, the variable first points to a reference right there in the middle. The reference is a space in the computer's memory, and that memory points to a value of the array 10, 20. Now, if I was to edit the array first, well, then I simply go to the variable, which points me to the reference, which points to the value, and I edit the value by adding 30 to the end of it. However, if I then try to assign, if I repeat this process before, but then I create another copy of the same array, well, here we see what we saw in the first example, which is I happen to have two values that are identical, but they're distinct, right? Modifying one version of the array has no impact on the other version of the array. And I know that to be true because, lo and behold, if I look at the reference values for the first variable versus the second variable, notice that they have different addresses, or sorry, different references. If we go to our and then editing one will not change the other, as you can imagine. If we go to our last scenario here, then, which is say I have a variable called first, I give the array 10, 20, and then I say let second equal to first. Well, now when we were looking at primitives, what we would do is we just make a copy of that array and give it a brand new version of it. But with complex values, because they are able to be changed, it's actually not sufficient for us to make a copy of it. We actually have to use that exact version of the reference, or sorry, that exact version of the variable. And so what that means is now when on line 3, when I say assign the variable second the value of first, the JavaScript is going to go to first and ask you what kind of value are you? Are you a complex value or a primitive value? First we'll say I'm an array, so I'm a complex value. And then JavaScript will say, great, give me your reference. I will now point both the first variable and the second variable to the same reference. And if two variables are pointing to the same reference, then by definition, they have to point to the same value, right? Remember, the reference is an address. If I say, go to 123 Broad Street in New York City, well, there's only going to be one address or one place with that address. So if I tell multiple people to go to that same address, they have to all end up at the same place. Same exact thing here. By pointing multiple variables to the same reference, they inherently have to point to the same value. However, what that means now is if I edit the value through one variable, in this case, if I edit through the second variable and I push 30 to the end of the array, well, that also means now the value of first has been changed as well, because first was also pointing to the same variable. It's like me and my friend are sharing one notebook. If I write something in the notebook, well, now that change is also affecting my friend as well, because we don't have different copies of the same notebook. We're sharing the same exact notebook. And so that's why, and hopefully that gives you a little bit more clarity around why earlier in the example with primitives, once I set the value of one equal to the value of the other, I could change them both and they wouldn't impact each other. With complex values, if I set them one equal to the other, changing one will change the other one as well. Any questions so far?
So I figured that using reference opposed to just logging the parameter, we're going to see how to use reference instead, right? I guess.
I'm sorry, can you say it one more time?
Where is reference posted? Is there somewhere that we can access that?
You don't. I mean, you could. You don't really need to see the actual references. JavaScript handles it for you. The only thing here we're trying to tell you is that on line 3 there, when I'm assigning one variable equal to another variable, just note that if it's a primitive value, then JavaScript is assigning a copy of the value. If it's a complex value, then JavaScript is assigning a copy of the address. And so what that means is with the primitive, you're creating two different versions of the same value, and you can treat both independently. With complex values, you're actually both looking at the same value, and so if you change it for one variable, you're going to change it for the other variable too.
I got you. All right, thank you.
Yep. And so now if I take a look at why first.slice is really powerful for us in some cases, or and actually a lot of times when we use slice, it's actually on an array. It's actually not to create a subset of the array. It's just to copy the entire array. The reason why this is powerful now is because if I want to create a copy of first and I want to make changes to it, but I don't want to modify the original array, well, by slicing the array, I'm actually just creating a different copy of it, which then I can kind of tweak and play around with, right? And so here, if I set the variable second equal to first.slice, if you look on the bottom right-hand corner, on the second variable, I've created a new reference that happened to have the same value as the first array. And so therefore, when I push 30 into my second array, it has no impact on my first array. Yep. So what do we actually pass values back and forth? Well, actually, one of the most common ways that we do it is something that you've been doing every single day since this curriculum has started, right? When we actually pass values into functions. Remember, every workshop that we've done so far, it basically has been starting as where we started is, hey, write me a function that takes in a number and does something to it. Well, when we pass that number into the function, that's the same as us creating a new variable and assigning a value to it, right? And so let's take a look at how that works in more detail here. On line 1, I have a variable called mynum, and I give it a number of 10, which is a primitive value. On line 3, I've created a function called adds20 that takes in a num, adds 20 to the num, and returns a num. Okay, and on line 8, I invoke at the adds20 function. I pass in mynum, and I capture the output in this variable called return num. Okay, so if I pass in 10 on line 3, I've created a new variable called num, which is equal to 10. On line 4, I set num equal to num plus 20. So num is equal to 10 plus 20, which gives you 30. On line 5, I return 30. And then on line 8, that 30 becomes the value of my return num variable. If I console log out my num and I console log out about return num is 30, but my num is still 10. because at no point in my code did I ever reassign the mynum variable. When mynum was being passed into the as20 function, what did JavaScript do? JavaScript didn't take that version of mynum and pass it into the function. It created a copy of that of mynum and passed that copy into the function. So whatever we did to that copy inside the adds20 function, it doesn't get reflected in the original mynum. That's not the case, however, with complex values. Here, if I have an array of the number 10, which is a complex data type, and I have a function called pushes20, which takes an array, pushes 20 into it, and then returns the array. On line 8, when I invoke pushes20, I pass in my array. JavaScript is going to ask you, okay, great, what data type is my array? It's a complex data type. And so I'm going to pass in that reference or that version of the array with 10 in it. So now the array on line 3 is going to be the same as my array on line 1 because I'm passing in on line 8 there. And then on line 4, I'm going to push 20 into the end of my array. I'm going to return the array, and I'm going to capture the array being returned in the variable called return array on line 8. So when I console log out my array and I console log out return array, they have to be the same thing. And indeed, by modifying the array inside the function, I've also modified the myArray variable outside of the function, because once again, both myArray as well as the array inside the function, they were both pointing to the same reference. And so by changing the array through the reference, through the array reference, I'm also changing the value of the array under the myArray variable. Make sense? Good. Is making sense to folks? Hopefully.
Yes.
I believe I'm following. Yeah.
Cool. That's pretty much it then. So that's the crux of today's lesson, right? When we talk about pass by value, that just means I'm copying a primitive value. When we talk about pass by reference, all that means is, hey, I'm actually going to give you the reference to the original one, and you're going to both be modifying, both working off of the original version. And so now we'll kind of solve our last mystery, which is why does triple equal sign not work for arrays or objects or complex data types? And the reason why is because what the triple equal does for complex values is they compare them by reference, not by the value. And so here, if I have array 1 and array 2, and they both have the same value, well, array 1 does not equal array 2, right? Because their references are different. Both variables point to a variable, but both point to an array. But those arrays, even though they have the same value, they're being stored separately in different parts of the computer's memory, so their references are different. And if I change array 1 or I change array 2, those changes will not be reflected in the corresponding array. However, if I do array 1 equals the array 1, 2, 3, and I set array 2 equal to array 1, now both array 1 and array 2 are pointing to the same reference, which is going to point to the same value. But when I compare array 1 to array 2, JavaScript is going to tell you, yep, these two are true because they're pointing to the same reference. That means they have to also ultimately share the same value at the end of the reference chain. And so that's why when we talk about using equality operators, be very, very careful when you use the triple equal sign to compare complex data types. Okay. When you're using triple equals, you're not comparing it based on the value, you're comparing it based on the reference. And so last but not least, if we go back to our old friend .slicing, I talked about earlier about how .slice allows you to create a copy of an array. The one thing that's a little bit of a caveat or a little bit of a wrinkle to that is when you use .slice to create a copy of an array, you're only creating what we call a shallow copy, or rather a copy that's one level deep. Here on line 3, I have an array 1, which is a nested array, right? It has two elements in it. The first element is a number. The second element is another array. If I copy array 1 using .slice and I store the output in the variable array 2, the variable array 2 when I print out is going to look the same as array 1. But even though I've used .slice, what .slice will do is it will go through every single element in the array and it will ask, are you a primitive or are you a complex data type? If you're a primitive data type, I'm going to copy the value. So in this case, we're going to copy the 1. Okay, so far array 1 and array 2 are distinct. They both have two arrays and they both have a different version of 1. When that slice gets a second element, which is the array 2 comma 3, it will say, oh, you're a complex data type. Let me copy the reference for you into array 2. Okay, and so therefore array 1 and array, even though array 2 is a sliced version of array 1, and they have distinct values for the first element. When it comes to the second element, they are still sharing the same references, or they're still sharing the same reference to the array 2 3. And so that's why on line 7, when I console log out array 2, I get back something that looks just like array 1. If I console log out does array 1 equals array 2, I get back false. But, and sorry, this is a little bit fast forward. This is line 7a, are we just saw. But in the original array, if I now push 4 into the end of my second element, so into the array 2 3, I push a 4 into it, and I console log out this corresponding value in array 2, the second element in array 2, you'll notice that even though I added the second value in the second element in array 1, that change was also reflected there on line 11 in the second element for array 2. And that's because the second element for array 1 still shares a reference with the second element for array 2. That slice only copies one level deep. That's why we call it a shallow copy. And so if I, on line 13, if I do the ultimate test of saying, is the second value of array 1 equals the second value of array 2, I get back true because they still share the same reference. This making sense to folks?
Yeah, that makes sense. Can you do like array.1 slice dot slice or something? Can you like push it?
So one of the problems will actually ask you to try to create something that copies a little bit more in depth, and then we'll also revisit the way of how to make a proper kind of holistic copy when we do our section on recursion. For now, this is more of a just kind of like an FYI. Dot slice will make a copy for you, but it's a shallow copy. So if you have nested arrays or nested things inside of there, those won't be copied by value. They will still be copied by reference.
Cool.
Yeah. And then does someone else have a question too?
No, I just realized it was I misremembered how to operate dot slice because you need to leave the parentheses open for it to print the result somewhere. So I answered my own question. No
okay, cool. Yeah. That's it for me for today. Like I said, the concept itself is actually, I think, very straightforward, and hopefully it demystifies a lot of what we've seen so far. This shallow copy is probably like it takes everything we just talked about and puts it in kind of one little compact thing. But are there any questions around the triple equal signs, around complex versus primitive data types, or any questions about what it means when we say pass by value versus pass by reference?
I just want to make sure that I understand the concept correctly. So array 1 has two elements in it. It's got that primitive 1 and the zero index, and 2 3, which is the complex array in the second element.
Yep.
Use array 1 dot slice, it's going to stop after the 1 in the 0 index, and that's where it comes into line 10 with the second point. It's only or on line 10 you have array 1 with the brackets 1.
Sorry, let me cut you off right. Okay, sorry. When you so array 1 doesn't stop after the first element. It will go to the first element. It will say, are you a primitive or a complex? And in this case, the first element is a 1, right? So it's a primitive. So it will copy the value of the 1 into the new array. It will then get to the second element, which is an array 2 comma 3, and it'll say, are you a complex or a primitive? It'll be, I'm a complex data type. I'm an array. So then dot slice will copy the reference of that second element into the second position of the sliced array. So it will go through the entire array. And so therefore, when I print out array 2, it's going to look identical to array 1. The only difference is the second element in array 2 is going to share its reference with the second element of array 1.
Okay.
Does that make sense?
Fairly. Yeah. Would you be able to go one more ahead where it shows what the console log would be?
Sure.
Okay.
All right. So on line 4, on line 10, what I've done is I've edited the second element of array 1. And all we're trying to show you is that that change was also reflected in the second element of array 2. And once again, it's because the second element of array 1 shares a reference with the second element of array 2.
Okay. Okay. Yeah. All right. I'm picking up what you're putting down. I got you.
Cool. Cool. Any other questions from folks?
Nope.
Everyone's good? All right.